Hello everyone, welcome back again. In this video we'll be using some data to come up with a linear model or polynomial model or exponential model. It's very easy by using Geogebra. So this is you might already have been familiar with this the basic interface of Geogebra graphing calculator. To work with basic spreadsheet calculation or statistics, then please press this button with 9 square dots, and you have several options: graphing calculator, geometry, 3D calculator, scientific calculator, and Geogebra Classic. So go to Geogebra Classic. Then you can see that you have a new interface, and you can go for spreadsheet. So this is where we input the data. So you get a version of table, a basic version of table, and you can use your data and use basic and have basic statistical analysis, which we'll be using in college algebra. Okay, I want to hide this button. Okay, so let me hide this. And if you ever want to find that again, then you can press this button, which is the keyboard key at the left bottom. And now let me input some data in here. Let me type some data in here. Let me come up with data. So this is Excel. I have previously typed this data. This is a random data. Okay, it copied more, so let me delete it. And here you can see that the first row, the first column is year since 2000. This is first year, that is 2001, second year 2002, and so on. This is and median income in $1,000. Okay, in $1,000. So let us select this data. Okay, let us select this data by using your left mouse click and click on this bars. Okay, click on that bar, and you have various options: one variable analysis, two variable regression analysis, and multivariable regression analysis. Now in our course in college algebra, we would like to go for two variable regression analysis. Okay, so click that. Then you will see this data points will be plotted. Okay, column A is x-axis, column B is y-axis. So you can see how it looks like. Okay, so this is how the scatter plots look like. Now you can go for regression model. Okay, so far there is none. So we have several options. If you click there, then you can see linear, log, logarithmic function. Linear means this data will use a straight line to model it. Log, logarithmic functions. Polynomial function, that could be x square or x cube, or higher powers. Power function, you'll learn it later on. The power functions, exponential functions, and this is sine function, means this is trigonometric, and logistic function also you'll be learning it later on. Okay, so for now let's just go for linear. Then you can see there's a straight line, this red line. It is trying to fit the data that we have in our spreadsheet. Okay, and you can see the red line has equation y equals 1.58x plus 31.33. Okay, so 1.58 is the slope and 31.33 is the y-intercept or the initial value. Okay, and now to find various important information, I would ask you to click on this button, summation x or sigma x, capital sigma x. Then you will see various important summary statistics. Okay, so mean of x is 5.5, so mean of this one or average of this x-axis. Mean of y means average of y-axis, column B, which is 40. And this we won't be going through sx, sy or other things. We will just be going for small r and r square. those are the two things that we would be looking at whenever we are trying to model our data by using GeoGebra. Okay, so R is correlation coefficient and R square is square of this one. Okay, this is small r, which means how well is the data fitted by using linear model. Okay, now so that's all about this small statistics table, and you can furthermore change the models. Let's go for polynomial model and let's see what kind of function best fits the model, best fits the data. Okay, let's go for polynomial model. Then you can see polynomial model, the equation would be y equals to 0x square 1.53x plus 31.42. So here basically it is saying that you won't be able to model it by polynomial model. Similarly, let's go for exponential function. Then you can see the exponential function is y equals to 31.92 e to the power 0.04x. Okay, so this is exponential curve. Let us go for logarithmic curve and let's see how well it goes. So this is y equals to 30.65 plus 6.19 ln of x, natural logarithm. Similarly, let's go for logistic curve. It's also y equals to 92.63 divided by 1 plus 1.94 e to the power negative 0.07x. Okay, so this is the way how you try to look at different models. And as we change the models, make sure that you realize this r and r square will also change. Okay, make sure you realize that. So for linear, if we try to fit this data by logarithmic function, then r will be 0.9163, r square is 0.76. Similarly for exponential function, look how it has changed. This r square has changed. Okay, you can see how. So that's all for this tutorial. So keep on exploring. We'll be using this GeoGebra tool, especially in chapter number 4 and later on in chapter number 5 for polynomial functions and equations. Thank you.